Hello, 7th graders. Today we're going to look at what happens when you have two events that you want to calculate the probability of them happening at the same time. So these are called compound events when you have two or more simple events. And there's a couple ways that we can solve theoretical probability of compound events. But the first one we're going to look at is setting up a table or a sample space. So remember, a sample space includes all possible outcomes. So we're still going to look at all possible outcomes and then have the probability equal the number of outcomes of an event over all possible, or the total number of outcomes in the sample space. So that denominator is still our sample space. All right, so in this example, Jacob rolls 2 fair number cubes. Find the probability that the sum of the numbers he rolls is 8. All right, well, we're assuming that each cube has 6 faces. So you have 6 outcomes on the first cube and 6 outcomes on the second cube. So step 1 is to use the table to make a sample space. We're going to do that now. Notice this table over here. That's where we're going to set up the sample space. So we have outcomes on cube 1 in blue, outcomes on cube 2 in green, and we're looking for the sum, that the sum of the numbers he rolls is 8. So I'm actually going to add these numbers together. So if he rolls a 1 on the first cube and a 1 on the second cube, the sum of the cubes is 2. Sum of 1 and 2 is 3, 1 and 3 is 4, etc. Why don't you guys pause the video for a second, fill out this table, and then play it back, and we'll continue from there. All right, so now we have our sample space set up. Step 2 is how many possible outcomes are in the sample space? Well, we know how to find area of a square, and area is going to count how many units. We have 6 units this way by 6 units this way. 6 times 6 is 36. So there are 36 possible outcomes. The entire sample space has 36 outcomes. So circle the outcomes that give the sum of 8. I'm just going to highlight those. Here's all my 8s. Notice they're in a nice straight line. How many ways are there to roll a sum of 8? Well, that's 5. There are 5 8s on the board. So what is the probability of rolling a sum of 8? Well, remember, probability is the number of outcomes that fit the description, so that was 5, over all possible outcomes, so the sample space, which is 36. So 5 over 36, that's our probability of rolling a sum of 8. And let's reflect on this just a little bit. Give an example of an event that is more likely than rolling a sum of 8. Well, if we look at our sample space and our possible sums, it looks like a 2 and a 12 are pretty unlikely. There's only one event where that's going to happen. But look at all these 7s. There's 6 7s. So rolling a 7 is more likely than rolling a sum of 8. And then give an example of an event that is less likely than rolling a sum of 8. Well, we did that. Anything over here is less likely than rolling a sum of 8 because there are less outcomes that fit that description. All right, let's see another example. A deli prepares sandwiches with 1 type of bread, white or wheat, 1 type of meat, ham, turkey, or chicken, and 1 type of cheese, cheddar or Swiss. Each combination is equally likely. Find the probability of choosing a sandwich at random and getting turkey and Swiss on wheat bread. So step 1, again, is to make our sample space. So we're going to start with the types of bread. We have white and wheat. And for white, we have ham, turkey, chicken. For wheat, we have ham, turkey, chicken. And then for each meat type, there's another 2 types of cheese. So if we're looking at our total possible outcomes, we can count the numbers over here, or we could do 2 times 3, 2 types of bread times 3 types of meat times 2 types of cheese, which is 12. If we count them over here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is also 12. So you can either count them individually or multiply 2 types of bread times 3 types of meat times 2 types of cheese. There are 12 possible outcomes. And look, we just did step 2. There's 12 possible outcomes. So find the probability of choosing turkey Swiss on wheat bread. Turkey Swiss on wheat bread is only one outcome, so that is 1/12. All right, pause the video, see if you can do 3 and 4 on your own, and then play it back to see if you got it right. All right, so use the diagram from example 1 to find the given probabilities. A ham sandwich, well, that would include, here, I'll switch my color. Ham sandwich would include these outcomes and these outcomes, so that's 4 out of the 12 possible. And we could also figure that out by knowing that ham is one of the 3 types of meat. So ignoring the type of bread and the type of cheese, it's still 1/3. Meaning the probability is 1/3 that a ham sandwich is chosen. All right, number 4, sandwich containing Swiss cheese. Well, let's switch the color again. We got Swiss, Swiss, Swiss. Looks like it's every other because there are 2 types of cheese. So containing Swiss is 1/2. Probability is 1/2 that a random sandwich would contain Swiss and not cheddar. All right, one more example for today. The combination for Kiam's locker is a 3-digit code that uses the numbers 1, 2, and 3. Any of these numbers may be repeated. Find the probability that Kiam's randomly assigned number is 222. All right, well, he has numbers 1, 2, and 3, and you can use them for any of the 3 digits. So we could figure that out by doing, okay, there's 3 options for the first digit. Those 3 blanks represent my 3 digits. So there's 3 options for the first one, 3 options for the second one, 3 options for the last one. And then we multiply. 3 times 3 is 9, times 3 is 27. There should be 27 possible outcomes. Now, another method of finding the sample space is by actually setting up the tables representing the sample space with all possible outcomes. So notice these 3 tables all start with a 1. So these represent the 3rd digits changing. So if you had 1, 1, 1, 1, 1, 2, 1, 1, 3. Now we have a table with all 2s in the second one, the last column still changing, and then all 3s in the second one, last column changing. Then we have to do the same thing for 2s, where you have 1s in the middle, 2s in the middle, 3s in the middle, and then with all 3s with the rotating middle numbers as well. So if we were to count up every single row here, because each row represents a different combination, we would see there are 27 possible outcomes. So these are the steps of finding the sample space. List all the codes that start with 1 and have 1 as the second digit. Start with 1 and have 2 as the second digit, and then 3, and then repeat that for 2 and 3. So we have our sample space set up. Yes, that's kind of a pain to set up 27 rows. So again, you could just set up, okay, I have 3 numbers and there's 3 options for each one, and then multiply. It's a little easier to do here. So find the number of outcomes in the sample space by counting all possible codes. There's 27. Find the probability that Kiam's locker code is 222. Well, that's only one outcome. That is only this row here. So the probability is 1/27. All right, we're gonna do number 5 here. I want you to pause the video, try it on your own, and then play it back to see if you got it right. All right, Martha types a 4-digit code into a keypad to unlock her car door. The code uses the numbers 1 and 0. The digits are selected at random. What is the probability of getting a code with exactly 2 zeros? So there's 4 digits. There's 2 options for each digit. So 2 times 2 times 2 times 2. That's 16 possible. And then I need to try to think of all the possible outcomes that have exactly 2 zeros. So we could have 0, 0, 1, 1, 0, 1, 0, 1. All right, so it looks like there are 6 possible outcomes that have exactly 2 zeros. So our probability getting a code with exactly 2 zeros is 6 out of 16. All right, your homework today is just the notes video, but tune into the Google Meets because these 8 problems will probably be assigned tomorrow or the next day.